Hi everyone, my name is Vaughn Stewart. I'm the Vice President of Technology Alliances within our team here at Pure Storage. In today's video, I want to discuss with you Splunk SmartStore and Pure Storage, and particularly discuss how the architecture helps deliver a joint value proposition that accelerates your search performance, greatly reduces TCO, and delivers agility and simplicity at scale. The target viewer for this video should be a storage admin who has to support a Splunk team, or the Splunk team who wants to understand how to get more out of their Splunk infrastructure and reduce management costs. This video runs about 10 minutes in length, and if you don't have time available to watch it today, press pause and come back to it. It'll be here. So with that, let's dive into this. What I have presented for you on the left-hand side of the screen is a simple diagram representing a classic Splunk indexer cluster. Now, there's lots of servers in the Splunk environment, different roles like forwarders or search heads. My apologies there. We're going to look at the indexer cluster because it's the only level where there's storage inside of the Splunk infrastructure. And so what I have here, and let me explain it to you briefly, is I've drawn 3 rectangles representing a Splunk indexer server, so small cluster. Below that, I've got small volume of storage is connected to or provisioned to each of the indexer servers. And you see it's got the words hot and warm. This means this storage is storing hot and warm Splunk buckets. Hot and warm data tends to sit on high performance storage, right? It helps with processing of that data while it's in the hot bucket, and it helps for the search performance when it's in the warm bucket. So this might be SSDs, if direct attached storage, maybe this is an all flash array. But this is my explanation of the hot tier, if you will. As I move down to lower in this architectural diagram, you see there's some larger volumes, and I have the word cold here. Cold refers to the cold bucket within Splunk, and this is sitting on lower cost, lower performance storage, usually disk-based storage, whether SAN or NAS or direct attached, doesn't matter. For those who are unfamiliar, there is no difference in the makeup of the data that sits in a warm bucket or a cold bucket. The difference between the two terms is what tier of storage do they sit on, and what is the performance of searches against that type of storage. And so cold tiers within cold buckets within Splunk, they were introduced as a means to reduce the cost of storage within the infrastructure. And so this is our baseline that we're going to work off of. This architecture, Pure has helped lots of customers accelerate the performance of this architecture, as well as reduce the storage capacity requirements. So let's talk about just some simple math we can work as we flesh out some of the details here that we're going to compare to SmartStore. So let's say the customer has a 1 terabyte rate of data ingest. They are running enterprise security, which is pretty common. That means you can ingest about 100 gigabytes of data per indexer per day. We're going to retain this data for a year. And there's a high number of searches that occur within the first 30 days of that data. So say 30 days is kind of hot, if you will. If we apply that sizing to this classic architecture, what you're going to find is you're going to require about 365 terabytes of total storage. And the math behind that's pretty simple. We're ingesting a terabyte of data a day. Splunk processes that data and compresses it, so that reduces the terabyte to about 500 gigabytes, or to about half of its capacity. And then Splunk, by default, will make replicas of that data. We're working off of the minimum number of replicas here being 2, so 1 terabyte compresses down to half a terabyte, makes 2 copies, and we're back to a terabyte. We're storing for a year, 365 terabytes of storage. If we've got 30 days of hot data, we probably have about 30 terabytes up in the hot and warm tier, and then we've got the remaining in the cold tier. In terms of the number of indexer servers, we're probably going to require approximately 19 servers, or indexers, is probably a better way to say it, each with 20 terabytes of storage. So the rationale behind the number of servers is relative to the amount of addressable storage provisioned to each server. We find that 20 terabytes is pretty common in 2019, plus or minus 10% for a lot of our customers. The rationale behind the capacity per server has to do with server maintenance, and we're going to go into that here in a minute. So while these numbers can be played with some, you may say my environment's got a different replication factor, or we assign more or less storage per server. We're just going to stay with this example as we walk through this. You can play with the numbers and they're going to apply as, if you want to do your own math as we go forward. But this gives us a baseline. So you remember at the top of the video, I said this video conversation is for both storage admins and Splunk admins. And so for those who are more storage inclined, we're going to go one level higher up into this infrastructure to really understand the value of SmartStore by explaining some of the server management sides within classic Splunk indexer clusters. And we're going to start with, if I need to add an additional indexer server, I may need to do this because I've got more storage I want to support. Maybe my rate of ingest has increased. Maybe we're performing more searches. Whatever the rationale may be, right? I basically have to provision another server, provision more storage from the hot to support the hot tier, provision more storage to support the cold tier. And so that's kind of the first phase. What happens after that is that all of the storage in the cluster has to start writing data across all the tiers. And this is called rebalancing. This means the entire cluster is going to read all of its data and rewrite all of its data across every node. This is pretty common in the analytics space, whether we're dealing with like a Hadoop cluster. This is common in the HCI space. It's also amenable here to Splunk. And the basis for this is because there's replica copies. The architecture, even if it's on a SAN or a NAS, still behaves if it's on a direct attached storage. And so this rebalancing means when we add a server, or add an indexer, I should say. When we add an indexer, we've got to rebalance. And rebalance can take hours. In addition to this, when we're looking at something like a software update, whether we're talking about the Splunk binaries, the operating system, a security patch, whatever it might be at the indexer level here, customers tend to do those online so that the search can remain available, as well as ingesting new data can continue to process. And so in order to do that, this process tends to be serial, meaning we're going to upgrade one server like this one here. And when we do so, there's going to be some data evacuation. When the data has been evacuated, ensuring that the RF factors are met, so all data is still online. Then the upgrade happens, and then the data is resynchronized back. So we've got data movement. And then the process repeats each server within the cluster. So again, we say we do serial or serialized updates. And those take time. And so for a cluster, it's going to be measured in days. Larger clusters roll into weeks. But this is what I want you to understand, which is I think the storage team really understands this level, but I want you to go a little deeper in your knowledge and understand the life of your Splunk counterpart and the Splunk team that you're supporting from a storage perspective. So now let's pivot and let's start talking about SmartStore. Before I can do so, though, I'm going to need a Splunk infrastructure. So here we have our Splunk diagram architecture, I should say Splunk SmartStore diagram architecture. I know several minutes have gone by, so I want to remind everyone as I go through this architecture, I'm going to highlight how Splunk SmartStore and Pure Storage can accelerate your search performance, reduce your TCO, and deliver simplicity and agility at scale. So let's dive into this a bit. The Splunk SmartStore architecture is Splunk's cloud-native architecture, now available for on-prem. It's comprised of stateless servers, an object store, a new concept called an index-aware cache. They've eliminated the cold tier, and it can be deployed either on bare metal, virtual machines, or containerized. Obviously, putting SmartStore on Pure Storage gives you an all-flash architecture. And as a reminder, where most customers are at today is some form of hybrid. And as we mentioned, hybrid meaning when you tier data down to the cold storage, it's slower, your search performance starts to slow down anywhere from 3 to 5x we see. Some customers try to even save more money on storage. They enable TSIDX reduction, and search performance falls another 3 to 10x, depending on the search type, and that performance data comes from Splunk's documentation. With SmartStore on Pure Storage, what you're able to have is flash behind all of your tiers and still get the advantages of TCO and agility and simplicity. And so allow me to elaborate. As data is ingested, it still hits your hot tier, as it does with classic Splunk. As data is processed from the hot tier and ends up now in a warm bucket, that bucket is automatically pushed down to the object store, and that's where it persists. The object store with SmartStore is responsible for data services like data protection or any enhanced services like data reduction. And we'll get to that in a minute. In terms of sizing the cache, it's very similar to what you'd size with classic Splunk. We said we've got about 30 days of data that we actively search, so we still want to search, with a terabyte a day ingest, we want to search over 30 terabytes within that hot tier and that cache tier. And what this means then is for our sparse searches, for anything that's not satisfied by the cache, we're going to service that with all flash, unlike slow disk and maybe even some slower steps taken to that disk. This means when you have something occur within your infrastructure that was unplanned for, your Splunk architecture is prepared. We see customers have to respond to cybersecurity threats. They have compliance and regulatory requests. Obviously, GDPR is a big concern for many. In addition, we see legal discovery, as well as like customer engagement, transaction disputes, things of that nature, forcing customers to go back to that cold tier and spend days to retrieve that data. So the SmartStore architecture, because of this design, adds an extra element that you can't have with classic, which is the ability to dynamically burst and add more indexer servers. You do so without having to rebalance any data. And so from a Splunk perspective, now you've got a set of agility that you never had before. And I'm kind of drawing over here over my stuff. So let me break this down in our comparison. With SmartStore, with the data reduction technologies and the pure arrays, and with the object store storing a single instance of the storage, our storage requirements reduced from 365 terabytes to roughly 150 terabytes of storage based on our example of a terabyte of ingest and a year's worth of retention. From an indexer server perspective, we lose the notion of having to size servers with the amount of addressable storage in mind because we've got a big object store behind us. So now we just size the indexers based on their ingest rate. Our example is 1 terabyte. We're using enterprise security. That means 100 gigabytes of data can be ingested per day per server. So now we go from 19 servers down to 10 indexer servers, right? Significant reduction in capacity, servers, networking ports, software licenses, not Splunk licenses, but your operating system, your antivirus, your security patches, things of that nature, right? Significant TCO reduction just out of the architecture itself. With the ability to dynamically add indexers, we can now add indexer servers without rebalancing data because everything persists in the object store. We can do this now. Instead of hours, we can do this in minutes. In addition, we are able to do a rolling online upgrade or update of the indexer software. Again, whether it's Splunk, whether it's the operating system, security patches, whatever it may be. And instead of having to move data, as we had to in the classic architecture, the indexers basically stop and complete whatever data they've been processing. They stop ingesting any new data. Once the data is written down to the warm tier, they go into maintenance mode and update. So now you can do updates of indexers in parallel. And so parallel updates can have an exponential impact in terms of the time. So you can update the whole cluster now in hours. These are radical gains in terms of what's available for the Splunk team that sometimes the storage team may be unaware of. In addition, I want to highlight 2 more capabilities that are unique to SmartStore. Let's start with this ability to add servers in minutes. Because we can, now we can do a burst. We can burst on demand. And what do I mean by that? Well, I shared with you having a high performance data store is going to support you for sparse search needs. Say you have one of those critical events happen, and maybe it's compliance related, where you've got a time that you have to respond to an inquiry or a notification. We've got all kinds of power here in the Flash blade ready to support that sparse search. Because you can add servers in minutes, because you can automate that addition, whether it's virtualized or containerized, and the fact that these indexers can be mixed and matched. Some can be virtual, some can be bare metal, some can be containerized. It doesn't matter. You can now burst this cluster on demand, radically accelerate that sparse search that you're trying to process. Once you've achieved the results or the data set that you need, you can retire those assets. You can just deprovision them, return the compute resources to whatever pool you pulled them from. That is something that, because of the time constraints and the movement of data, is really not impossible, but so impractical that you would never be able to do that in production with classic Splunk. The last benefit that SmartStore has is it allows you then to replicate this data to the cloud, like Splunk Cloud, and now you can do DR as a service. High performance searching capabilities on-prem, your DR up in the cloud, so you're not maintaining two stacks. Right? Obviously, you can still do on-prem to on-prem if you'd like, in terms of building out a replication and a DR, a replication relationship and a DR deployment. But this is something that, again, is new and unique to Splunk SmartStore. So this is Vaughn. I've gone way past the 10 minutes that I said this would take. My apologies. I've shared with you a lot. Hopefully what you've been able to see is how Splunk SmartStore and Pure Storage allow you to accelerate search performance, reduce your TCO, and deliver simplicity and agility, particularly at scale. Because I've shared a lot with you, let me show you where you can find more information. You can go online to purestorage.com. You can go to my blog, vaughnstewart.com, and I'll have more technical conversations like this one. Actually, this whiteboard broken down into multiple posts. Or you can reach out to any of Pure's partners and ask them to set up a meeting so we can discuss Splunk with both your storage team and your Splunk team, and we can go from there. With that, thanks.